Hey guys, welcome to Section 3, Chapter 7 of the Geometry program. And this section is so jam-packed and we're going to hang out here for several days that I actually split this video into two parts. So we're going to deal with special right triangles of the 45, 45, 90 kind today. And then tomorrow we're going to deal with 30, 60, 90 triangles. But this is something that you're going to see on every standardized test that you're going to take from here on out. It's something that I feel like, generally speaking, the traditional schools spend very little time on when it's something that we see so consistently when we prep for SAT, ACT, college placement exams, things like that. And it's really fun. So we're going to hang out here for a little bit. Hopefully it won't be too challenging. So we've been talking about the Pythagorean theorem and we've talked about Pythagorean triples. And another cool thing about right triangles is that they have special relationships when you're in a 45, 45, or in a 30, 60, 90, like we're going to talk about tomorrow. The sides have a special relationship. And in the 45, 45, we call that 1, 1, square root of 2. Mind you that it's 1, 1 because these two sides are congruent in a 45, right? Remember, a couple chapters ago, we talked about when you have base angles the same, then we know that the sides are the same. And if two sides are the same, you know you're in an isosceles triangle. But another way to think about this that might be easier as we begin to solve is that the side lengths are x, x, and then x square root of 2. And we're going to use these side ratios to save us from always having to do Pythagorean theorem. Pythagorean theorem will always work in a right triangle. If you have two sides, you can use that and you're good to go. But we have some cheats in these special right triangles. And so what we're going to be doing is learning how to be able to come up with the missing side lengths without always having to crunch the Pythagorean theorem. Okay, so let's jump in. Let's say we have a 45, 45, 90 triangle. And you're given side length 7. And you need to find the other side lengths. Well, you know that both of the legs have to be the same. So clearly that guy also has to be 7. But then because we're in a 45, 45, remember I just drew you a triangle that said that the side lengths of a 45 can be represented like this. So you can take that 7 and multiply times the square root of 2, and that is your missing side length. All right? A whole lot faster than the Pythagorean theorem. All right? So when you're given a leg, actually, this is super easy, right? Again, we have to be in the 45. Let's say this is 5. Then this has to be 5. And this is 5 times the square root of 2. All right, not bad, not bad. All right, what if the side length is 2 square root of 2? All right, so I know that this guy also has to be 2 square root of 2. But for the hypotenuse, what I need, my x is 2 square root 2. And then I need to multiply by the square root of 2. So what does that look like? So that's 2 square root of 2 times square root of 2. And the square root of 2 times the square root of 2 is just 2, which means my side length is 4. Okay, so you're going to have to be using those algebra skills too in order to be able to deal with those radicals. All right. All right, this time they give us the hypotenuse. It's 8 square root of 2. And we have to find the two legs. Okay, so remember that this is x, x, x square root of 2. So when you're given this ratio, if you don't see it, this one's pretty obvious, but there'll be a couple where there's not so obvious. You could actually make a replacement here and solve. Right? So 8 square root of 2 equals x square root of 2. And now we can solve this for x by dividing by the square root of 2. And x would have to equal 8. And x is my side length here, right? So both my side lengths are 8, which would make sense, right? Because if we didn't know this was 8 root 2, and I knew that the side lengths were 8, we would say, okay, the hypotenuse is 8 root 2. Okay, let's do another example like that. Because these are super easy when you're given the leg. It's a little bit trickier when you're given the hypotenuse. All right, how about I change the orientation of my triangle for you? Okay, let's say you're given the hypotenuse of 6. This is 45, and this is 45. So you're looking for your legs. Both of them are x, right? And this side represents x square root of 2. So go ahead and set that up as an equation to solve. So in order to solve for x, I need to divide both sides by the square root of 2. So x is going to equal 6 divided by the square root of 2. Now, if you remember in your algebra, we did not like radicals in the denominator. So we have to rationalize this by multiplying top and bottom by the square root of 2. So you get 6 square root of 2 on top. Then the square root of 2 times the square root of 2 is simply 2. And then remember, this is all your algebra skills, when you have two numbers outside of the radical that can be simplified, we're going to go ahead and do that. 6 divided by 2 is 3, and you keep the square root of 2. So our side lengths are 3 root 2. Now the nice thing about these problems is that you can always check them, right? So we're saying that the side lengths are 3 root 2. In order to find the hypotenuse, I better be able to take 3 root 2 times the square root of 2 and get 6, right? That was given to me. All right, well, square root of 2 times the square root of 2 is 2, and that is 6, so I know that I am correct. All right? All right, let's do another one like that. These are tricky, I recognize. So let's do one where the hypotenuse is 7. Again, you're in a 45, 45. And I think the easiest way to solve this is by recognizing that this is equal to x root 2. That is the side ratio. So if we set that up and solve it by dividing both sides by the square root of 2, then x is going to be 7 divided by the square root of 2. Now, we have that square root of 2 in the denominator again, causing us trouble. So we rationalize by multiplying top and bottom by the square root of 2. And now you're going to get 7 root 2 over 2. Now that can't be simplified any farther because 7 doesn't divide evenly by 2. So now your side lengths are actually 7 root 2 divide 2 and 7 root 2 divide 2, which makes us feel very uncomfortable. I recognize that, but it's good for you. So just follow the side procedures and you should be fine. Let me do one more example for you. If you don't need it, go ahead and finish up the video and you can begin your assignment. But there are a lot of students that tend to struggle with this concept, so I'm going to just do one more example for you. Again, if we know that the sides are 4, then this is 4, 4, 4 square root of 2. Super easy. Okay, but what happens if my hypotenuse is 4? Remember that this represents the side length x square root of 2. So we're going to set that equal to each other. And then I'm going to divide both sides by the square root of 2. So x is going to equal 4 divided by the square root of 2. But that square root of 2 is in the denominator again, that pesky denominator. All right, so now we're going to multiply across and get 4 square root of 2. Square root of 2 times the square root of 2 is 2. And now we have two integers on the outside that can be simplified to 2 root 2. So our side lengths become 2 root 2 and 2 root 2. Okay, your entire assignment tonight is just working with the 45, 45, 90 special right triangles to try to get you proficient. Tomorrow we'll do 30, 60, 90, and then we'll mix them all up for you. So if you're ready, finish up your notes, read through the section, and begin your assignment.